Hey guys, welcome back to the shop. Frank here. I've got a problem with my mill, or at least with the Y-axis power drive unit. I installed it, I don't know, 2 years ago, 3 years ago, and it's one of those inexpensive Chinese drive units that you see. And I wound up installing a second one. It worked well, so I wound up installing a second one on the Z-axis. The mill came with the X-axis drive, so I haven't had to mess with that. But the Y-axis drive started acting up about a month ago. The fine speed control, the rheostat, or potentiometer that controls the speed of the feed, quit working in slow speed. So you would turn the dial and then all of a sudden it would be feeding quickly, way too quickly to use for anything but, rapid transit. It was almost as fast as the rapid movement button. And so for the project I was working on at the time, and it's on one of the videos on the channel, I don't remember which one, I wound up hand feeding everything. But this morning, I started looking at it again, playing with it, and I got it to feed slowly by very carefully moving the rheostat or the potentiometer, and then all of a sudden it quit working altogether. I mean, completely quit working. And I could smell something overheating or burning. I mean, it's an electrical insulation smell. So it's done something. So I thought I would take it apart and look at it and see if we can see what's wrong with it. I don't know if we can fix it or not. For some reason, if you go on eBay, and I bought both of these, the Y-axis and the Z-axis, off of eBay. The X-axis drives cost like $130, $140, $150. The Y and Z-axis drives cost $350. I mean, 3 times as much, almost. So I don't understand that. And if I have to replace this and spend, I think the ones I was looking at were $389 or $379. It just seems exorbitant when this exact same machine is $150 for the X-axis. I might be able to get away with one of the X-axis drives and use the components from the Y-axis drive I currently have. I have to look at that and see, but that's down the road. I haven't made that decision yet, though, with the fact that I let the smoke out of this drive unit. It may be there. I mean, I didn't see any smoke, but I could smell it. So there's definitely something wrong with it. All right, we're going to take it off the mill, put it on the workbench here, and see what we can figure out, if there's anything we can do with it. All right, so I don't know what has happened here. This is locked up solid. It doesn't, and that may be what has happened is I don't know, if it's locked up solid, then, I mean, the table moves, or did move. Well, that's, all right, let's plug it back in. I can feel the drive moving. Okay, it's clearly not working. All right, so it's unplugged. All right, we've got all the interface components. All right, so this is the motor drive, spur gear, and this is a song, whatever that means. I mean, that's the brand. The one I have on the Z-axis, which has been working fine, is, oh, there's a reset. Okay, so I just hit this reset button and that appears to have turned it back on, but you can see there's no motion, then all of a sudden it's very fast. So it should get a lot slower than that. So that's the rapid switch. Which is basically what's happening with that. There used to be a light here that would come on when you turn the power on. Okay, I can see it, but it's very dim. I don't know if you can hear the hum. So that's not right. That LED should be brighter. These are the motor brushes in here. I have a feeling I need to remove those. We're going to take the brushes out. That looks fine. Got some chips on it, but it doesn't look bad. Okay, the 4 screws. Looks like a little washer, lock washer. Alright. What do you think about taking this apart? What happens? It doesn't move. Alright, so I'm going to say this has to come off. Alright, so this is actually a half inch nut. Surprising. It's not 12 and 13 is pretty big on it, so. Looks like a drive pin here. Let's see. I don't see anything else holding it together. There we go. It smells funky. Alright, so already I can see this bulb. Looks like it's burned out. See how it's black? So that's one issue. Looking for any burned or melted traces on the circuit board. Everything looks fine there. Alright, so here's a potentiometer right here. Maybe what we can do is put a meter on it and see if we can see if it's the problem. And maybe that's a reasonable replacement. Let's plug it back in. We don't have the... Let me put the... So there was a wire in this wiring bundle which was pressed against the outside cover of the potentiometer, and it looked like it was blackened, like overheated. Insulation burned maybe a little bit. So I don't know whether it was shorting out. Looked like it might have been shorting out. So let's put these brushes in. Oh, okay, so you can see the light is on. So it's still doing the same thing. It is kind of an on or off situation. So I want to measure these outputs of the potentiometer, and I don't want to short my probes against this housing. Let's see what we get for readings on the potentiometer. All right, we're going to go mode, kiloohms, auto, megohms. All right, so it drops from 2.3 megohms, 2.3 million ohms. I turn the dial, turn the dial, turn the dial, turn the dial, turn the dial slowly. There, it drops to 4 kiloohms, 4,000 ohms. So about half of the dial is useless. And then it goes down to 2, 1, 0.7 ohm. That's basically full speed. 85 ohms. So half of the dial motion of the potentiometer results in no change in resistance. I think it's a bad potentiometer. The only easy way I see to remove this potentiometer is move the motor. And I think it's just 2 cap screws here. I just need to move it enough to get the potentiometer past it. And we got to get the brushes out of there. Now they're in the way. So I pulled this back cover off the potentiometer with the intention of cleaning it with deoxit and or contact cleaner. But the issue is it's broken. The resistance element, film or material, is broken. So it's separated right there. So it starts here, goes all the way around, but it's separated there. So we were only getting a part of probably this part. So as you can see, the contact wiper goes around. So in this part, it's on unattached piece, and then it finally comes onto this piece and operates for, part of a turn. So a third of the turn, it's not contacting anything. I had no luck finding a replacement. And DigiKey, Mouser, eBay. Maybe I could. Well, this is made in China. There's no way they're going to have parts available for it. I think it's a loss. I think it's a total loss. I'll think about it. Maybe I'll come up with another idea. All right, so it turns out that the Y drive unit is not easily repairable. I showed you the failed potentiometer. I spent several hours trying to locate a replacement. None to be found. And the one which was, I think, close was $50 or something. So I didn't feel like it was worth spending $50 to replace a potentiometer on a drive unit. I purchased the cheapest one, almost the cheapest one, on eBay. A Vivor X-axis unit. It was only $112 compared to the cheapest was $369, $379, something like that for a replacement Y-axis drive. All right, I looked at the two units. They look pretty similar. I figured any differences I could deal with. So let me show you the differences. So there is a difference. The diameter of this is different than the diameter of this. So the original unit had this sleeve. The new unit has this sleeve. Apparently the X-axis shaft is a different diameter, so the sleeve is different, and the outside diameter is different. But I got a lathe, so I think I can turn this down to this diameter. I only need to turn it down for this distance, an inch or so. The rest of it fits inside the machine's not really relevant. All right, so that's one change. And the other change is the drive gear. Now this is the old one, and it fits in here and fits on the shaft like this, and it fits fine, but it's a couple thousandths larger. The bore is several thousandths larger than the replacement gear, and the teeth on here are different, so they won't mesh. You can see the teeth on this gear are straight. This has got a spiral, so I have to use the gear that came with the new unit. But those are the only two differences that I see. Well, the diameter is a little different, but the new gear will fit in. The new gear will fit in here. So I've got it over on the lathe, so we'll go over the lathe. We're going to bore out that brass gear that came with this unit, the new unit, just a couple thousandths, so it'll clear the shaft, and then we'll turn this sleeve down to smaller diameter. Let's see, you can see the difference in diameter. Okay, and we'll come back and install the new unit. I've got the new gear here in the chuck, and I've got the boring bar mounted, and we're just going to take like 2 thousandths off. That's all we need. All right, so the new gear fits fine. I mean, there's virtually no play there, so that's a good fit. All right, now it's time to turn this sleeve down. All right, so 160 thousandths is 80 thousandths off the radius. Touch off here. All right, touching right there. 75. All right, so let's do 20 thousandths. That's a problem. That's hardened, apparently. So let's need to take enough of a cut to get it to cut, so we'll go 25. All right, 0.999, so we need another 50 thousandths on the diameter. So we're going back to, that's where we were. .97. So we're still .20 thousandths. Let's get another reading here. 0.980. Still need to take 37 thousandths. I'm still showing a few thousandths off. The only way for me to get a clean cut, a good finish on this lathe with my tooling was to take a large depth of cut, 25 thousandths. I can't get the speed on here. The lathe doesn't have the rigidity. Alright. But it feels pretty smooth. Let's go see if it'll fit. And the turn down bushing fits in there. So there's a little bit of play, but yeah, I don't think it's any more than the bushing that came with it. So, and since it's just to support this, I think it's going to be fine. The finish on it's not perfect. It is pretty smooth. There are some little striations on it, but that's the best I think I can do with my lathe. And I think it'll be fine for this application. Okay, so I've got the parts modified. We can put this thing on. That's dry. We have to grease that. Okay. But I think that'll work fine. There's the sleeve. I've greased the bearing here. It fits fine. Okay. When I originally installed this, I had to drill and tap 2 holes. So I need to get back into those 2 holes. So I found another issue, and that is the distance between the holes in here is not the same as the distance between the holes on here. Not off by much. And I think the easiest thing to do is just going to be get a drill bit and enlarge these holes a little bit. And just do that by hand. All right, that did it, I think. There's the key. And I completely removed the grease since I had this on the lathe and was boring out the interior here just to make sure I didn't have any brass filings in. I completely cleaned this and re-greased it. All right, I just plugged it in. Okay, seems to be working there. All right, the next thing we need is our guide here, but we want that to be separated. Let's see. That's the shims I had on the last installation, and that's about right. So it doesn't quite touch this. Okay. Then Vevor gives you a plastic nut. This is the original steel nut I'm going to reuse. Fortunately, it fits. Okay. Let's just check it here. Okay, working. There's another key. Get the shaft turned around here. All right, so I need to get this key in here. All right, I've got this key fitted. That's going to be a problem. We need to change keys here. All right, I had to come back and put the longer key up front because these two keys do not align, so I need a very short key here. And even that one's too long. So there's an issue. This is shorter than this is longer. That's another difference. So the key there is for this handle and the nut to fit on there. All right, so that should work. Not many threads engaged on here. I just need to, actually I could reduce this by a little bit. All right, so I shortened this key up just a little bit. There we go. All right, that fits. So each installation requires a different number of shims. You just don't want this dial to rub the housing. And it's got, and probably doesn't need, I could get rid of one of these. Yeah, you want it to be close but not rubbing. And then now each installation is going to be a little different. Actually, I may come back and take a little bit off the end of this brass sleeve. The issue you're going to have is when I first installed the original drive, I had to mill off these two balls in order to clear the housing on the original installation. And I mean, there's only a little more than 1/8 of an inch clearance as it is. So I could take 1/8 of an inch off of that. Let's see how it works. So it's going in. Coming out. All right, I think that works. Who's here? It's my Bucci and my Brew Brew. How you guys doing, huh? You being good boys? Yeah? You being good boys? You out there causing trouble? Huh? Alright, that's going to wrap up this video. Brutus. These guys. Alright. So, I kind of took a chance on ordering that X-axis drive to replace the Y-axis drive unit. I don't know why the Y and Z-axis drives cost $250 more than the X-axis drives on eBay. They look the same, they function the same. Well, the attachments may be different, but I took a chance, figured I could adapt it, and if I couldn't, you know, I'm not out that much money. It was only, what'd I say, $112. So, and it worked out. I think it's working fine. It'll serve my purposes. The only thing I can think of is that they sell a lot more X-axis drives because that's usually the first one that, you know, people will put on a mill. My mill came with a good X-axis drive, so I never had to buy one. I bought the Y and Z drives, and to be honest with you, I don't remember how much I paid for them. Whether I paid the $300 or whatever they were at the time. So it's been 4 or 5 years. I need to get back on the tractor project, so that'll be the next coming up video. I do have another jib crane to install. I've shown you the one I have over by the plasma table. One of the things I'm, trying to deal with now is moving my 10 or maybe it's 12-inch rotary table onto the mill. I mean, it's so heavy. I'm afraid I'm gonna hurt myself picking it up. I mean, it's got to be 125 pounds or something. So I'm not as young as I used to be. I'm always looking for ways to get old, and if those of you that are my age, and a lot of you are my age, based on the YouTube stats, you start looking for ways to keep from hurting yourself. So I'm not as strong as I used to be, and I don't heal as quickly as I used to. So lifting something too heavy is definitely a deal breaker. So I'm trying to avoid that. Anyway, so I got another jib crane, just like the one over on the plasma table, only it's not electric, it's manual. So my plan is to install it here next to the mill, and it will allow me to pivot, bring something over on a roller or hand truck, pick it up and get it on the mill without having to physically pick it up myself. I been thinking about some kind of a crane gantry system in here, but it's just too complicated in this building. I didn't plan ahead enough. I guess when I built this shop, I built it as a woodworking shop, and I wasn't thinking about moving heavy metal stuff around, and so it's not conducive to that. So I'm just dealing with that. But that'll be another video probably in a few weeks when I get that installed. So that's going to be a wrap on this video. Give me a thumbs up if you enjoyed the video, and subscribe if you haven't already. I appreciate everybody watching, and we'll see you on the next one.